Okay, so as we have seen that we have created one tree class where we have defined certain kinds of attributes like height, diameter, tree type, and also we have defined one behavior, or you can say this as a method, that is grow, in which we are just increasing the height by 10 and increasing the diameter by 1. So this is the basic prototype, or you can say kind of uh, a blueprint for the tree objects that we are going to create in the tree type dot that we are going to create in our main class. Okay, but before creating this kind of objects, we need to know one thing about building objects from the blueprint. So clearly this is our blueprint, and we have to build objects or create objects from this blueprint. So classes basically are the blueprint, but these becomes tangible when we use constructor to create an object, right? So as the name suggests, this constructor is basically used for creating the objects from the class. Okay, so in the name only there is this construct. Okay, so it is used to create objects for the class. Okay, so class basically is the blueprint, and when we want to instantiate or when we want to create the objects from a class, then we use make the use of this constructor. So constructors are very much important. So definitely for our tree class, if we want to create a object for the tree class, we need to call for a function, special type of function known as the constructor. Okay, so let's see how we can create a tree object from the constructor. So I'll go to my code, and there I will be defining a constructor. So the way we define a constructor is by writing the tree name. So of course this has to be, mhm. So we can change this to let's say rename it, because as for the convention, the class name should be starting from the capital letter. Okay, so there is should be this rename option. I can't find it here. Okay, so let's rename it here from this. It's showing an error. What's this? Okay, let's rename then. We don't have here rename. Just want to rename this file, but okay, fine. But however, as for convention, this should be a capital one. Okay, so we can do this. Let's delete this entire code. Let's delete this class, and we will create a new class with. Okay, let's create one new class here, and let's name it tree.java. Okay, it will be created here, so we won't need to worry about. And now you see the class name is all caps. So we will be pasting the code that we copied off. So okay, and here we will change the name to the caps. Okay, so this works. Now we are going to create a constructor so that we can instantiate our class, right? So this is how we are going to call this constructor. So this constructor is basically a special type of function, and this constructor name is same as the class name, so that it returns. There shouldn't be any return type, because this tree tells us that this is a particular. This will create a return an object of tree type. Okay, so to build a tree we need to know what should be the height and diameter and of course the tree type, because these are the basic attributes that will help us to identify a tree. So whenever a tree is created, we need to pass out the height and the diameter of course. So this double height. Okay, then we have this double diameter, and then we have this tree type. Okay, I think this autocomplete function is working right now. Tree type, and there should be tree type. Okay, so these are the basic attributes that we need when we are defining a tree. And then we will construct this. So okay, what happened? Okay, just a second. Think it's not created. So of course, here we are going to assign the value provided with the tree class. So this are the whenever we are creating a tree object, we need to provide one height, diameter, and tree type, and then we will be assigning all these data to the particular attributes of that tree. So this dot height equal to height, right? This dot diameter equal to diameter. Then we have this dot tree type. Okay, this should be tree type equal to tree type, right? So here we have provided assigned the value to the actual attributes of that particular tree object. So whenever we are instantiating this class with certain values of height, diameter, and tree type, all these value will be getting assigned to its attribute that is originally owned by that particular tree object. Okay, so we will see next what I meant by this. So here this means that we need to add inputs to the constructor so that when we construct the custom tree with the appropriate height, diameter, and type. Okay, of course, here we don't have to do anything with the body of the function. We will need to set up the tree with the appropriate values. Okay, so to keep our class, this tree class, separate from the other part, the main part, we will create one class called the main class, where we are going to create the or instantiate the tree object. So we will click on this class, and let's say it is a main class, and definitely its name would be main.java. Okay, and let's create this class, and this is our main class. So here we have this public static void main function, where we are going to instantiate our tree objects from the tree class. So here I would like to make one object for the tree, that is tree, and let's say the name of the tree is oak. Okay, so equal to new tree. So here we are calling the constructor with certain values, like 25 would be the height, then 5 would be the diameter, and then we are providing the tree type to be, uh, let's say the tree type to be oak. So we will pick up from here, and this is our tree type. And of course, this way we have created one tree objects, that is the oak. Okay, so this oak is one of the tree object we have created by providing the values like 25, 5, and the type to be given as oak. Okay, now let's print this particular tree height. Okay, so system dot out dot println, and here we are going to print this oak dot height. Okay, so this one, right? So let's see if it is printed, but it is showing some error. Okay, so what is this error? Okay, this println should be print, right? Okay, so let us just execute this command. Okay, there is one more error here coming up, so let's see what it is. It's tree object and tree type is undefined. Okay, so do we need to save this? Okay, let's save this. Now this error has vanished. Now let's run this program, and we will execute the main from here. Okay, so you see here it is there, some error has occurred. Okay, what's the error is? Mhm. Let's just rebuild this. Okay, so there is some error occurring up here. Uh, okay, let me see why this error has occurred. Let's build from here, run as Java application. Let's save this file first. Okay, this is package.oops, and we are calling it here from here oak.height, and of course it should run, but there is one reason why it's not running. Run as Java application. Okay, let's see why this error is occurring up here. Mhm. So, okay, and here, Java, what's there in module? Mhm. Okay, this one is not working. Let me see why it is not working. Okay, actually the problem was in the Java compiler. So here I have set this Java JRE to JDK 17, and now if we try to run this main, we get this output as 25.0. That is the oak height that we have already provided here as 25. If we try to print the type of this tree object that we have created, let's see if we can print it out. So it will be oak dot tree type. Okay, so tree type would be this, right? So if we try to print it up, let's see. Okay, so you see here it is printing as oak. Okay, that is the tree type of this particular oak instance of the tree class, right? So in this way we can do the instantiation, and then by we can create and constructor to construct the object of the class, right? And here we can call this constructor by providing the specific value for the particular instance. Likewise we can create another object as such. Okay, so this is actually how we instantiate a class, right? Now we have still not done some application logic part, like in the tree.java we have this instances, we have introduced this constructor so as to instantiate or to create an object for the tree class, right? And we have one method, but it does like this is a method for the particular tree class. Let's try to call this method. Okay, so however something anything not will be printed here. So let's do some application logic, and we will rewrite our code such that we get some message printed out when we have a tree greater than a particular height. Okay, So let's say we are doing some logic here. So let's check that if the oak dot height, okay. So if oak dot not height, it would be yeah, height only. Okay. If oak dot height greater than 100, then this is a we need to print something like okay, dot out. So we are going to print that this is a tall tree. Okay, and this we will be printing out. Let's give this a value of let's say 250. Okay. Now we have provided a value of 250, and we need to see that whether it is a tall tree or not. If we try to run this part, you will be seeing this as this is a tall tree. Okay, we haven't changed the line here. Right. Let's rerun this. So see, we got this as a tall tree, right? Okay, rerun this again. Okay, so we are now getting the formatted output, right? So we try to print something based upon the height. We check the height of the particular object and then we printed out something. Let's, for the sake, let's create another tree object. Okay, so we can print actually. Sorry, we can copy these lines and let's create a new instance of the tree object. So let us call this time as it's a maple tree, and here we can change the type to okay, tree type dot maple. Okay, and here we are going to print its height and of course its tree type. Okay, so and we are again going to check the height of that and we are going to print the message if its height is greater than 100. Okay, so we will copy this part and again we will check and give one more check, and here we are going to check for the maple dot height. For the sake of simplicity, what we will do that we will write the type as well. Okay, this is a tall and plus sorry, plus here we need to plus we introduce the tree type and plus then this tree. Okay. So we are saying that this is a tall maple dot tree type and then tree. And for here also, we will copy this part, this oak dot tree type. Okay. So that we can guess what is what. Okay. So here we will add this part. So I'm sorry, this is should be closing and then plus oak dot tree type and plus tree. Okay. So right. So we have made two objects of the tree class. One is the oak and another one is the maple. First of all, we are printing both their height and tree type, and then we are doing some logic here. We are checking up the height of the oak tree, and we are seeing that if it is greater than 100, we are simply printing out this message, and same as goes for the maple. Okay, if we will be having other objects as well, we will be printing for them too, right? So this, I think, what is this problem? Um, okay, and okay, I believe this is it, right? So let's rerun this. We will save this part. Okay, I think there is some problem in this line. Let's fix this up. Okay, so there is a syntax error for the main part. I think we need to introduce one, right? Okay, that will work. So let's save this up and we'll see. Okay, so as you see, I think there is no space here. So that is why it is. Let's rerun it again so that it could be formatted. Uh, okay. So here you see that this is a tall oak tree and this is a tall maple tree because both of their height has been set to 250, which is greater than 100. Okay. Likewise, we can have many such instances because we have already created a constructor, and every time we call this tree part with certain attributes in it, the constructor method will be called, and the associated value are assigned to the height and diameter and the type of the tree, and a particular instance of the tree class is created. Okay, so we need to add this input to the constructor so that we can construct a custom tree with the appropriate height, diameter and type. Okay, so this is the actual reason why we have introduced the constructor here, right? Because every time we are instantiating this object for this class, we have provided the height, diameter and tree type, which gets assigned to the attributes of the tree class. Okay, and a new instance with the particular attributes gets constructed, right? So to keep our class clean, we have used this main.java where we are creating the instances of the tree class, right? And here we have created two instances by providing the appropriate values to that, and we are have introduced some application logic also, so as to check that if a tree size or height is greater than 100, then we are going to print as it is a tall tree. So this is one of the thing that we can do. But you see, if we keep on creating other instances, we need to add the same logic, the same if conditional part again for another tree, and so on for other instances that we create. For example, this is oak and maple. Let's create one more object, and for that also we need to introduce this conditional. Okay, so every time we are checking the conditions for that, and so it doesn't sounds to be a good method uh, for the part. Like if we are keeping on checking this if condition, we are not using the code reusability feature. We are just again and again we are using the same logic, same conditional. For example, here also we are doing this height check, and here also we are doing this height check for different objects. So why not we can have one function which would check this height, and for every object we can call the same function, and our output will be printed for that. So for that reason, what we are going to do is we are going to copy this, cut this part from here. Okay, and let's say we go to this tree.java, and let's introduce one more function here, void. So since this function returns nothing, so we can introduce one function void, and we can name it as announce all tree. Okay, and this is one function, and let's add body. If we add it here, so we are definitely we will be getting this errors. Why? Because we don't have this oak and maple defined in this class. So for this, we are going to change this to this dot height, and here also this dot height. Okay, so I think it will be a repetition. We will delete this part. So there will be only one if. Okay, and this dot height corresponds to the height of the object or the instance that will be created from this class, right? And here also we are going to print its type as this dot t type. Okay, and right. So this is one function we have created for all the tree object. So every time a tree object will be created, we will be calling this function, and that will check and that if its height is greater than 100, then definitely it's a tall tree. This will be printed. So let's check this function here. So here we are going to call this function for our objects created. For example, oak dot announce tall tree. maple also, we are going to create the same, call the same function. So now install tree. Let's save this code and check the logic here. So here it goes. So for maple, it is a tall maple tree, and also for the oak it is a tall oak tree. Okay, because this function is created in the tree.java class, and it goes for every instances, right? So for every instance we can call this announce tall tree method, where we will pass the corresponding height and we'll check if it is a tall tree or not. Okay, so this is how we can reuse our code, and we can get a better code, right? Like this allows us for the code reusability feature, right? So we have already written the check in the height in the main class for oak and maple tree, so we can make use of this code as reusable if we add more instances to it. Similarly, we can have other methods also, right, in the tree class, and it can be used or it can be shared by all the instances that we create here in the main.java. Okay, so this is about the object, instances, classes, and of course behavior, right? So it is also related to reusing the functionality. Okay, so here we will use this comment using the functionality, and what functionality we are using. So this is announce all tree function which we have created in the tree.java class. Okay, so it makes our code very much cleaner. You'll see we don't have to write multiple times if here. So one function and the problem gets solved. Right. So with the tree blueprint, we are able to announce the attributes and behavior, and all these attributes and behavior are reusable. With that, we are able to create instance and keep the track of various trees. Right, so this is about the object oriented part. Next, we are going to see something about the static and the non-static members. Okay, so that we are going to see in the next upcoming video. So till that, goodbye and keep watching. Okay, so thank you very much for watching.